Faraday generator or magneto optic method. So by using this method, we have to measure very high value of direct currents. Okay. So this operating principle is called Faraday effect. Okay. When a linearly polarized light beam passes through a transparent crystal in the presence of magnetic field. Okay. So like this. Light beam is passed through a crystal through a polarizer. Understood? When a linearly polarized light beam passes through a transparent crystal in the presence of a magnetic field, the plane or polarization of the light beam undergoes rotation. Okay, this rotation plane of polarization is proportional to the current. Okay, so this light beam is passed to the crystal through a polarizer. Okay, and then current, this crystal is placed parallel to the magnetic field, and also this current flowing conductor is placed to the parallel to the magnetic field. Then this light beam is rotated like this, and they reflected back to the uh, from the crystal like this. So this reflected beam is passing through the analyzer and a filter, and to the photo multiplier, and then CRO. So we have to measure by using CRO. We have to measure the waveform. Okay, very high value of current. Okay, so working principle. So when a linearly polarized light beam is passed through a transparent crystal in the presence of a magnetic field, planar polarization of light beam undergoes rotation. This rotation of plane of polarization is proportional to the current. Okay, so this angle of rotation is proportional to the B into, okay, L is this is called L. L is called length of the crystal, and B is called magnetic flux density. Okay, the angle of rotation. Okay, so angle of rotation, this is called our light beam is passing through the crystal and is rotated like this and reflected back. Okay, this is called angle of rotation, is depending upon magnetic flux density and length of the crystal. Okay, and the angle of rotation is equal to V into B into L. Okay, angle of rotation is equal to V into B into L. V is called constant of the crystal. It depends upon the wavelength of the light. We use the constant of the crystal is depending upon wavelength of the light, and B is called magnetic flux density, and L is called length of the crystal. Okay, so this is the working principle of this method for measurement of high current, Faraday generator or magneto optic method. So in this construction and operation, okay, in this construction of an operation, so try to construct a stabilized light source, a lamp. This is called a stabilized light source, a lamp emits beam light. These beam light are felt on the crystal through a polarizer. So in this way, through a polarizer, this light beam is passed through a crystal through a polarizer. Okay, the crystal is placed parallel to the magnetic field produced by a current I of t. The crystal is placed parallel to the magnetic field produced by a current. This is called I of t. Okay, this crystal is placed parallel to the magnetic field. Okay, the crystal is placed parallel to the magnetic field. It's produced by a current I of t. Due to Faraday's effect, the light beam undergoes rotation of its plane of polarization. Undergoes rotation because of plane of polarization. Okay, so the beam is now passed through a analyzer. Okay, the beam is passed through the analyzer and then filtered by using filter. By using filter, so this beam is can be filtered by using this called filter. So after analyzer, so that signal is come forward to the filter, transmitted to the filter. Okay, the filter is allow only monochromatic light and is passed to CRO through a photo multiplier. Okay, by seeing the output display of oscilloscope, the current can be measured. In this way, we have to measure this very high value of current. Simple concept. So we have to transmit. We have to apply the light source through a crystal through a polarizer to crystal through a polarizer. After that, this reflected beam light is passing through the photomultiplier through a analyzer and filter. The filter is allows only monochromatic light. Okay, and light is passed through the CRO, and that CRO, by using CRO, we have to measure very high value of current and also waveform. Okay, and the device cannot be operated for DC currents. This is one of the drawback of this method. Okay, this device is cannot be used for measurement of DC, only for AC. Faraday generator or magneto optic method is suitable for only measurement of AC only, not for suitable for DC. Okay, and next advantages: no electric connection between the source and the device. Okay, no electric connection between the source and device. Okay, there is no direct connection to the source and device. Okay, no thermal problems even for large current in the current of several kiloamps. No thermal problems for large current of several kiloamps, and no insulation problems arises for extra high voltage system. Okay, because of signal transmission through a optical system. So these are the some similar advantages of this method. Okay, this is about Faraday generator or magneto optic method for measurement of high voltage, high current.